Hello everybody and welcome to your 45th chapter in your Java E7 tutorial series. In this tutorial, we'll be talking about the Java messaging service concepts. So, getting right into it, what is the Java messaging service API? Java messaging allows you to create, send, receive, and read messages using incredible services like asynchronous and loosely coupled communication while being reliable all the way through. This communication is loosely coupled because the sender and the receiver don't need to know anything about each other more than their destination. This is how messaging differs from tightly coupled technologies such as remote method invocation, RMI, which require an application to know a remote application's methods. I also want to make clear that JMS and email are not the same. Email uses third-party softwares like Gmail to process messages from person to software application to person, and while messaging is used for communication between software applications, email is for people and JMS is for software applications. JMS is also asynchronous, like I said. The receiving client does not have to receive a message at the same time a sender has sent a message, and it's reliable. With the JMS API, you can rest easy knowing that the message will always be delivered once and only once unless specified otherwise. So let's get into the few basic concepts. Let's learn the concepts to start to write the most basic JMS API concepts. So the JMS API architecture first has your administrated tools. So these are factory-made objects that are made for JMS clients to use. Administration tools or annotations can be used to bind destinations and connection factories into a JNDI namespace. JMS clients can then, JMS clients are the programs or components that produce and consume the messages by using resource injection. Next, these things over here, these are messages. So messages are the objects that communicate information between the JMS clients. And a JMS provider is an implementation of the JMS interface that is used to establish a logical connection. So let's take a look into an example. So we have an administrative tool that creates a connection between our image of the LaFerrari and the name LaFerrari. This is essentially how a JNDI namespace works. It takes an object and it assigns it a name, so it's very easy to access this object. Then you can use this object, and let's say a JMS client wants to use this object. It can't use it on its own, so it gets some help from its JMS provider. The JMS provider gives a logical connection to the JNDI namespace, and then your JMS client can then use this object for whatever it needs. Okay, so just to recap over here, let's zoom out to how this plays out. A JMS client can be a producer, as you can see here, sending a message to the JMS provider, and another JMS client can then consume the message over here. This can happen both ways and even with the same JMS client. Now let's get into the messaging styles. Before the JMS API, there were only two ways to message: the point-to-point model, and now the publish and subscribe model, which is new for us. So let's get the basic idea of a point-to-point model. First, I send a message to a queue. So I go ahead and send a message, and a queue is like a line of messages that are waiting for you to check them out. Now you come along and you see that there are a few messages there waiting for you, and you take the messages out of the queue. So the point-to-point model tells us that, first of all, each message has its only one consumer, and the receiver only gets the message when he or she is ready to receive it. Until then, the queue will hold on to the message. Next, let's take a look into our publish and subscribe model. So this model is a little bit different. Let's take a really well-known application of this publish-subscribe model, YouTube subscriptions. Let's say that you subscribe to Viprov Programming, and I come to upload a new video. My video then goes to a topic, which is similar to like a bulletin board that sends the video to all my subscribers. Now you have my video in your feed and you can now enjoy it. If you had a durable subscription, then the topic will actually hold on to your video if you're offline for whatever reason. This makes it so you don't have to be on YouTube 24/7. So the takeaway from here is that the publish and subscribe model, each message can have multiple customers. So let's take a look into the consumption of these messages. There are two ways to consume messages, either synchronously or asynchronously. Synchronously consuming messages, so it's possible to wait for the consumer to receive the message and have that information relayed back. This is useful when your application needs to make sure that the consumer has definitely received the message. And asynchronous consumption, an application client can use a message listener to ensure that the message has been delivered to the destination, but it does not check if the client has received or read the message. This is useful when making sure that the message has been delivered, which has been delivered, is top priority. Now, the JMS API programming model. So these are the basic building blocks of a JMS application. So first of all, let's take a look into our connection factory. So these are used to create a connection to the JMS provider, which can then be used to create sessions for the producers, JMS clients that produce messages, and consumers, JMS clients that consume messages. This is how you would programmatically create a connection instance. So now let's take a look into our destinations. These are targets for our JMS client producers and a source of messages for JMS client consumers. In the PTP messaging style, or the point-to-point messaging style, destinations are queues, while in the pub-sub messaging style, they are topics. To create a destination using Glassfish Server, you create a JMS destination resource that specifies a JNDI name for the destination. The code shows how to specify a queue and a topic. Alright, so now let's take a look into our JMS context. This combines a connection and a session into a single object. This means that it has an active connection with the JMS provider and a single threaded context for sending and receiving messages. To create a JMS context, call the createContext method on the connection factory within a try with resource block to allow it to close after running. Next, we have our JMS message producers. So these objects, so an object is created by a JMS context or session that sends messages. You could create it either through example 1 over here, or you can create it in this second example over here if you want to create a new producer every single time you want to send a message. In this case, you create a variable, so you can use this variable to send messages, or you can create a producer every time that you want to send messages. Since producers don't take up a lot of space, this is usually what we'll be doing. Next, let's take a look into our JMS message consumers. These are objects created by a JMS context or session that receives messages from a destination. This is how you would go about creating it. So when a consumer is created, you can either consume a message synchronously or asynchronously. For synchronous consumption, you would go ahead and put in this code over here. This times out in 1 second. For asynchronous consumption, what you would do is you would use message listeners. Message listeners essentially listen for a message coming in, and if it does, it will run the onMessage method that you will define. You can register a message just like this. So if you would like to filter the data that comes through, you can use JMS message selectors. These are strings that contain an expression which is syntax similar to SQL. In this example, the message selector selects any message with the property of news type or which is set to the value of sports or opinion. Next, let's take a little delve into our JMS messages. The purpose of a JMS application is to produce and consume messages that can be used for different software applications. JMS messages have a basic format that is simple yet highly flexible. A header, properties, and body. Out of these three, only the header is mandatory. So message headers, these contain a number of predefined fields that contain values used by both clients and providers to identify and route messages. Message headers contain values like the message ID, the destination of the message, timestamp of the message, etc. Message properties are used if you need values in addition to those provided by the header fields. And message bodies change the way that you send and receive data in many different forms, like a string or a name value pair if you wish. So you may remember in a point-to-point model, there is a queue that holds on to the messages for the end client. Queue browsers allow you to monitor what is inside the queue and display the header values for each message. This is how you would go about creating a queue browser object. Now you might be wondering about topics. Unfortunately, JMS API does not have the facilities to browse a topic, but it does have the facilities to browse a queue. Okay, so now let's take a look into some advanced features. So to control message acknowledgement, until a message is acknowledged, it will not be considered as fully consumed. This acknowledgement happens either when the session is committed or the transaction is committed. A queue will keep sending the messages each time a client comes online until the message is acknowledged. So to specify options for sending messages, there are 4 options you can specify when sending a message. There are persistent messages, which mean that they must not be lost in the event of a provider failure. Message priority levels, which affect the order of which messages are sent. Expiring messages, which make sure that old messages are not sent. And delivery delayed messages, which send the messages after a certain time. You can set these properties all at once by chaining them together over here. You can see that, first of all, you can see that you can set the priority. Then you can set you can make sure that it's a persistent message. There's multiple, you can make sure that it expires in 1 second, and it's delayed. It's making sure that it's non-persistent. Okay, so now let's take a look into our temporary destinations. Normally, destinations are created administratively and not programmatically, but the JMS API allows you to create temporary destinations that last only for the lifetime of the application you've created. The only message consumers that can consume from this temporary destination that you created are those created by the same connection that created the destination. Any message producer can send to the temporary destination, and if you close the connection to which temporary destination belongs, the destination is closed and its contents are lost. So using JMS local transactions. Transactions are a series of operations that run in a specified amount of time. Transactions are incredible because if any operation fails within, the entire transaction can be rolled back, ensuring that no data is ever lost. If the data does make it, it is committed, which is like a confirmation that the data has been received. This makes transactions extremely useful in extremely data-sensitive areas like banking. Here's an example of transactions. As you can see, first of all, your client can send the transaction over here to your queue. And then this queue will send another transaction to the client that wants to consume that message. As you can see, the transactions are not done between client to client. Rather, it's client and destination, and another destination and client. This is what makes messaging different from synchronized processing. Since the client is not tied to any client here, the clients can change and switch without affecting the underlying code. This is what loose coupling is. So previously a message would be sent and it would block the application until the JMS provider confirms that the message was sent successfully. With asynchronous messaging, this block does not happen. It frees up the application to continue its job while waiting for the confirmation. And this is how you would send an asynchronous message. So using the JMS API in Java EE applications. There are 3 places you can use the JMS API. The EJB applications, the web applications, and the application clients. In the EJB and web applications, you must not create more than 1 active session object per connection. Multiple JMS context objects are permitted, however, since they combine a single connection and a single session. This rule does not apply to application clients, and the application client container supports the creation of multiple sessions for each connection. So what we can do is we can use annotations or the deployment descriptor. You can create connection factories and destinations that are visible only to the application you create them for. This is how you would create a JMS destination. And this is how you would create a connection factory. You use the JMS connection factory definition annotation. Now, to use resource injection in EJBs or web components. In Java EE applications, it's really common to use the @resource annotation to add in connection factories, topics, or queues. These would be created administratively, which means that it would be created in deployment descriptor files. There is one default connection factory that we use called the default JMS connection factory. You would declare the JMS resources in application client components as static. In contrast, resource injections are not static in session beans, message-driven beans, web components. So then you can also inject a JMS context instead of a connection factory, which would go something like this. So now using Java EE components to produce and to synchronously receive messages. One proper programming practice you will find with any synchronous receivers is that they will all have timeouts. This practice is followed to ensure that the application does not get tied up with a single message or just make it asynchronous. Using the JMS API in Java EE components, which is very similar to what we did before with application clients. The only difference are the areas that concern resource management and transactions. Resource management pertains to the creation and destruction of resources. As you may have guessed, resources take up a lot of memory and can cause performance issues if not closed and left roaming around. Usually the best way to remedy this is to contain the creation of a resource within a try with resource block. This will make it so that the resource is immediately closed after the block's job is done. If you wish to keep the resource up longer than that, you can use the @post construct and the @pre-destroy tags, which you have seen before. So to use message-driven beans to receive messages asynchronously. Alright, so now we're getting into the other option. So you remember our guy message-driven beans? Well, they're the ones that really make asynchronous messages possible. They basically say, don't worry application, I'll tell you if you get any message, if they get your message, you can go right on ahead. You may already notice, but I'll say it again. Once your message-driven bean finds that the client has acknowledged and read the message, it will then read the business logic inside its onMessage method. In many ways, a message-driven bean is like a stateless bean. If you would like to see an example, well, here it is. You see the message-driven bean is annotated with the @message-driven, and it has an onMessage which has all the business logic you want to run. Alright, so now let's take a look into managing JTA transactions. In this world, there are only two kinds of transactions: JMS local transactions and JTA transactions. The difference? We can have more control over JTA transactions than the other. An example of this is distributed JTA transactions. This is simply the ability for multiple applications to be able to do atomic updates on multiple databases. This saves time and is honestly more efficient than having to establish every single transaction. JTA transactions itself can be split into two different types of transactions: container managed transactions, or CMTs, and bean managed transactions, or BMTs. Container managed transactions will be the one you will be dealing with most. It is basically the transaction managed by the container, if you didn't figure that out. The container takes care of the integrity of the transactions you send through it. It takes care of the stuff like committing and rollbacks. You won't be seeing a lot of bean managed transactions though. They're used if you wish to apply more constraints on top of what the container does onto the transactions. And that's it. That's all there is about our tutorial on our Java message service concepts. I hope you understood how we can create, send, receive, and read messages using the incredible services in Java messaging like asynchronous and using the loosely coupled ability of communication. And now that you got all that, let's take a look into our next chapter, our Java message service examples. And you'll see all these concepts put into work. But until then, I will see you in the next video.